Well, now onto the meat of things. And I'm not sure if this is how you refer to it, but you are well known for arguing for and defending what I'll refer to as a tripartite model of muscle hypertrophy, in that there are three primary factors that contribute to muscle growth: mechanical tension, metabolic stress, and muscle damage. And can we go through these one by one, just explaining the ideas before we go into some of the applications of each for actual training?
Yeah, and I'll start by saying I don't necessarily argue for that.
Oh, okay.
My, and hopefully in my book, um, maybe it didn't come across, but certainly that my papers and my talks, I certainly discuss that we still are far away from knowing what the mechanisms are. So I think it's clear that mechanical tension or mechanical stress is the primary driver of hypertrophy. I don't think that's disputable. And that means that the body um, takes mechanical when the body is imposed or when a mechanical force is imposed on the muscles on the body, those mechanical forces are converted into chemical signals through a process called mechanotransduction, and that sets off a cascade of events, which ultimately ends up as protein synthesis, which drives hypertrophy. There are other potential factors that are involved. So my theory on this now, or my opinion, is that we're still a long way from knowing what the ultimate drivers are and their role. I think certainly there is evidence to support other factors being involved, but I don't think it's necessarily strong evidence. I think there is some evidence and there's counter evidence against it. So there's metabolic stress and there's, a lot of supporting evidence to show that metabolic stress, which is the buildup of metabolites during exercise, may contribute to hypertrophy. There's other evidence suggesting it doesn't. Or if it does, it might be tangential by having a non-direct role. There is some evidence that muscle damage is involved. There's other evidence that it's not. I think certainly as far as muscle damage is concerned, I think the evidence is pretty clear that if there's too much muscle damage, it's a negative, has negative effects on hypertrophy because you're going to be unable to train. And if you're not able to exert substantial effort during your training, that's going to have negative effects on your ability to grow. So what I would say is that we know that without mechanical tension, there's no evidence that the other factors promote substantial growth. There is some evidence, like with metabolic stress. There's some evidence that like blood flow restriction training, which causes metabolic stress, actually can attenuate atrophy and even have small effects on improvements in hypertrophy during disuse. So if you were they show when people are in a cast that simply tying off the upper portion of the thigh, so a cast on the leg, the upper portion of the thigh using blood flow restriction training can actually attenuate atrophy and even slightly promote hypertrophy. Now, what is regulating that? Is it metabolic stress? This is without any contraction. The leg is in a cast and can't move. It's immobilized. So could it be transient to hypoxia and other factors? Again, we just don't know. Cell swelling. So this is why it's very difficult to highlight and to learn about mechanistic factors because there's many confounding issues that can come about when we're studying mechanisms. So
Hmm.
say is that we can have theories, and the strength of those theories is going to be always predicated on the evidence that we have. And when you're not able to carry out very good studies, or when I say very good studies that are designed to really answer the question that you're looking to, you're going to have weaker evidence. You're going to have to start drawing your conclusions from evidence that isn't really, that's somewhat indirect from what you're looking to study.
Yeah, well, I'm sorry for mischaracterizing your position as arguing for this model. I guess I did um, misunderstand, or maybe my understanding has just warped over the years. But I talked to Eric Trexler on the podcast a couple of months ago, who I think you know, and we spent a good deal of time talking about the pitfalls and difficulties of extrapolating from mechanistic research to ecological validity. So I hear you quite loudly and clearly. But I am surprised because I thought that the metabolic stress and the muscle damage were far from questioned as drivers of hypertrophy.
Yeah, they certainly are. And again, I think if you're going to ask me, like, if I have to give an opinion, I think that they do contribute, but I think the effects are small, and how meaningful is that? Those are questions that it's really, I don't think we can have answers to. And to give a tip of my hat, Eric Trexler is a terrific researcher I have a ton of respect for. And yeah, I totally concur that trying to extrapolate how that actually then you can use that information in practice becomes even more challenging.
hmm I think this jumps ahead a little bit since we haven't spoken about some of the applicability of these ideas in actual training. But I wonder if you have any thoughts on whether paying attention to these secondary or tertiary aspects of training, like metabolic stress and muscle damage, might be much more important for athletes at certain stages in their training careers where they're trying to eke out all of the little gains they can versus somebody who's totally new to the gym where just touching weights will result in muscle growth.
Yeah, I definitely do. I think that for the not only the newbies, but people who are just satisfied, if your goal is not to be a bodybuilder or to optimize your genetic muscular potential, I think a lot of my research is just not really applicable. I think a very basic type of routine will get the majority of people the results that they're desiring, with some modifications over time. But really, where we're when I carry out research, it's about optimization, or much. Well, I shouldn't say much of my research is looking into optimization strategies, and then it's up to look. Once we know what optimizes something, it's up to the person to individual to decide and to extrapolate how applicable that is for them. Or
Mm.
a trainer, let's say a practitioner, a coach, personal trainer, to decide for whoever they're working with how important are these things. And you also have to factor in a person's lifestyle. If a person is limited in time, there's going to be limitations to what their genetic potential, or how close they're going to get to optimizing their genetic potential. So you're just not going to do it if you, let's say you have 2 hours a week to train. I would say that you're just not going to be stepping on stage for natural body. Well, you could step on stage, but you're not going to be a high level bodybuilder if your timing is very limited. So there's just certain basic factors that are going to need to be adhered to, and that's why everyone has to make their own decisions based on the evidence that we have.